I'm honored to introduce today's speaker, Dr. Henry Tirri, Senior Vice President and Head of Nokia Research Center. It is in a very new technology, mobile technologies, communications, and his main research area is in machine intelligence, particularly in the area of data modeling and data analysis. With his extensive experience and knowledge, I'm certain we can gain much from his wisdom and insight. Now, please join me in welcoming Dr. Henry Tirri, Senior Vice President and Head of Nokia Research Center.
So thank you. Good afternoon. It's actually, I can tell you, I mean, remember in your days, remember always professors also used to be students, although students tend to forget that. It becomes extremely embarrassing with the age, you know, to hear all these things, and you start feeling it, oh my gosh, there have been so many things. Most of my CVs don't tell the important things, like that I'm probably the only Finn that you ever meet that was a keen longboard surfer for 15 years. So that's actually much more important than some of the other aspects there. Today I'm going to talk about Nokia research, but not so much about Nokia Research Center per se. I'm going to touch a little bit the way we do work at Nokia Research, not for the reason that I want to particularly advocate organization or the processes or anything like that, but more of give you an idea what is it to work in a research lab, industrial research lab, and what sort of things might be a little bit different than if you think about academia. So I know academia very well. I spent 28 years, sort of, depending on what you count in academia. I spent 38 years of hacking, so I also consider myself enough of a hacker. I've seen a lot of computers in my life, from different sizes, from the sizes of the room, then moving to the small ones. But I also want to touch the topic that you all, by the end of the day, when you graduate, in most cases, if you are related with engineering, you have to touch it, one way or the other. You can avoid it, you know, being actually doing something at maybe with the mobile computers themselves, but the applications and the services and whatever you're going to do, whether it's on the sort of what you call in the cloud side or whether it's on the device side, you can't avoid the mobility. It just happens to be. So, of course, you can challenge me, so let's see if I can convince you that this is really the case. Now, what's my job? I have one of the coolest jobs on earth. So my task is to predict the future of computing, or in fact, if you look at the Nokia research labs, it's actually much more than just the future of computing. So I will return back to the type of competencies we have at the labs, basically. This was my favorite series when I was very young. Particularly like the early cell phone, which is of course shoe phone. But you laugh at this, but if you had seen the first analog what you call cell phones. By the way, it's only Americans that call them cell phones, reasons which I never could understand. It's like because of the cells of the base network. But basically, handset, it really pretty much looked like that. At least it was the same size, and it definitely weighed it more than the shoe. So, Maxwell Smart was pretty much good in predicting things at that point in time. Now, one of the things I want to touch first is that what does it mean to do research for me? I'm heading a Nokia research labs globally. That means that there's a lab in Palo Alto, there's a lab in Berkeley, there's a lab in Santa Monica, there's a lab in Cambridge, Boston, there's a lab in Cambridge in UK, there's a lab in Lausanne in Switzerland, there's one lab in Helsinki, the radio system, one lab in Tampere, one lab in Beijing, one lab in Shenzhen, one lab in Bangalore, one in Nairobi. What does it mean to me? What do I ask from my people when they do the research? Now, first thing what I'm asking for my people is that this is I usually show this slide because this was, I've just gotten married with my wife for this year 30 years. That point of time. No, 30 years ago. And I took her to a date movie, which was War Games. And You can imagine that I've learned something in the 30 years. It just showed how deep hacker or geek I was at that point in time. So every researcher that we have has to have a geek in them. Now, the geek can be very different geek if you're in psychology, if you're doing user experience research, if you do something else. But you have to have a tiny geek in you. If you don't have the geek, sorry, you're not going to survive long in Nokia research. There are other principles when you do research. And this is, by the way, also that I told always my students at the university. I had research groups in various different areas during my academia, is that oh, by the way, all these pictures are taken by me well, actually, all these pictures are taken by me. So basically, we only fail gloriously. When you want to do good research, you're a risk taker. You surf the highway. I mean, yeah, and most of the time it doesn't end up very well. But when you get the perfect wave, it's cool. So you only fail gloriously. If you fail, you don't want to fail because you just tried something very, tiny things. Or if you fail because you were sort of incompetent, that's nothing to celebrate. But you want to celebrate if you had a very high goal, you did a great job, but for some reason you either didn't succeed because there was external conditions that didn't make it happen, or there was something really in the problem that you couldn't, for example, solve. It was unsolvable, which is also a possibility. Why this is important for an industrial lab, again, a teaching for you, is that you will end up in a situation where external forces decide quite frequently whether the thing, your baby, your greatest innovation, that you think that everybody is a moron who doesn't immediately understand that it's a great product, and if the lab, if the company doesn't take it, you've got to go and make a startup. That happens all the time in an industrial research lab, because there are various business reasons, business landscape reasons, that certain innovations never go there. We are here in the Silicon Valley. We know all the story of Xerox PARC. Most of the interface stuff that you're using now originates from my friend's Alan Kay stuff. You're still using the same funny icons and this type of pointing devices and others. But as a tech transfer, it was a great innovation. As a tech transfer to the company itself, it was a failure. Absolute failure. Xerox PARC never utilized any single thing. So it's very important to reach hard. Second thing when you do, and this is more of almost a startup culture. This is, by the way, my sink at the Oak Creek Apartments. After 3 weeks, I travel a lot. I came back, and the neighboring apartment evidently had some problem clogging in the garbage disposal, so I pushed all the garbage to my sink, and when they fixed it, the water went out, but left all the garbage there. And it's after 3 weeks, I can tell you that when you come at 9 o'clock in the evening, you see this one, it's not so nice to start scraping. So something one has to remember, that if you believe, when you study and when you do things, if you believe that you can narrowly do, I'm super coder, I don't care anything about this, I'm just coding. I'm going to get my job, I'm just going to do this coding, or even worse, I'm just going to only do database coding. The other stuff is for other people. You will never survive. It's better to remember that this statement that I always tell my people, this is not my job, it's not something we use here. There are times when you need to do different things, and times you need to broaden the stuff that you do. Not all things are nice, like scraping this one, but they're very important to understand that if you want to work in a team, if you want to win, if you constrain yourself to be too proud to do other things, you're not going to succeed. Now, this is particularly obvious if you go to a startup. So I wouldn't even say it for a startup because it's obvious. But people often think that when they go to IBM or HP Labs or Nokia Research, where there are 1,000 people around, that I can narrow my job description to be very, very, very simple. The third principle, which is shamelessly borrowed and modified then, is a finger pointing. Every one of us has been guilty in our life of finger pointing, some more than some less. Finger pointing means that I'm actually not the faulty one. It's these morons that don't understand my great stuff, or it's actually the bureaucracy that is killing me. You know, the university is pushing me with all this reporting, it's very dull. The same happens at the university labs. And there's another finger-pointing thing that can also happen, which is like the technology transfer. We do the great innovations, but you know, the business groups, these guys, they don't get anything. That's, again, a philosophy that I do not encourage or do not believe in. So this statement is modified from a very famous phrase or a story. I learned in my teaching years, after this, you don't remember anything else except the stories. So I tell a lot of stories. There was President Eisenhower was visiting Yale. You know, Yale, a little bit knows it at that point in time. The faculty of Yale, and came there and say, I'm so happy to meet the employees of the university. So there was a physics professor. You know, physicists are particularly opinionated, at least my colleagues, where I have a training also in theoretical physics, so I can say that because I'm also opinionated. He was looking at President Eisenhower and said, we are not the employees of the university, we are the university. And there's deep truth in that. If you start thinking that I'm the employee, but there's some magic other thing that forces me to do different things, you're going to lose it again. Because you're then going to outsource the responsibility. You think that somebody else is responsible for that, so you're going to do, again, your thing, and nothing is going to happen. I particularly frequently quoted that at the university, by the way, so it's sort of fun because there's a lot of things that can go. And the final one is related to the culture that is somewhat pervasive in academia, but is definitely pervasive in industry and industrial labs, is the PowerPoints. You know, there must be PowerPoint runtimes nowadays already. Can't understand what else would it be, because everything is PowerPoint. So I've sort of challenged my people always that any PowerPoint that is presented to me must be grounded to reality. I wrote this slide not too long ago because I had a dream, actually a nightmare, more that I was put to lead one of the product lines in Nokia, one of the smart devices product line. And I remember in the dream, I was like, oh my gosh, I'm not totally sure. There's all these, BV, business development going on, production. I have to do the sourcing decisions. I have to go there and there. But I was like going around, and I was surrounded by an army of people who showed me all different plans and project charts and PowerPoints on different and other things. And I felt very helpless. But that's not the point. In the dream, I remember that, and at some point in time, I believed that I want to go and see at the plant what's really going on and how my product is doing. I mean, what's the prototypes are and what they are like. So in that dream, I went to Chennai, to the factory, and opened these huge doors on the factory, and it was a really big factory. It was like size of this campus, like the big factories are. And what did I see? In that dream, I saw 15,000 printers that were printing PowerPoints that were essentially pictures of the mobile phones. And I remember that in that dream, I was like, oh my gosh, it never grounds to reality. The PowerPoints still continue even when we are at the production level. After that, I did the slide because I realized that there's a great danger that you get into just building and building and planning and planning and planning, and it never grounds to reality. Okay, let's shift gears a little bit and talk about the era of computing. I've seen a lot of computers in my life, so I argue that each of the computing eras tend to have also research and research organizations which are native to that era, meaning that they are very good matches to that era. Bell Labs was very good for the original networking, information theory era. IBM Research also, in computing, when you look at the fundamental principles of computing, the early days of also the computing Moore's law, building architectures. There was an era of each of the era, for example, of application and database programming, and when Microsoft Research was established, it was very heavily focusing on the software as a research lab. This also point that each of these laboratories have a life cycle, because they tend to miss something, because they're matching to an era and then they miss something. So for example, a good example is that for a long time Microsoft Research missed the web, or sort of search engines and work. And then once they got the search engine team, then Bill decided that, okay, we need to do search anyway, so then they took the search engine teams from Microsoft Research and put them into production. This is the first computer I started computing with, doing so. It's HP 2014B. I always remember that number by heart. It has 16,000 bytes as a memory. I was programming it, the high-level language was BASIC, and you had paper tape, and it took half an hour to get the BASIC interpreter in with the teletype terminal. Most of the time, to doing better programming, and because you didn't have space, I wrote the machine code in Octal on the touch thing. So I was so fast of writing it with the touch. By the way, it had really these lighted touch sensitive buttons already. So you could put 3 machine words here, and you can, for example, read the code by just clicking it like this and doing the assembler decoding at the same time, or you went there and the best of us coders could code, few seconds per machine instruction, directly feeding it manually from there. Times were very different. Nokia N8 2010, million-fold storage capacity in the device of size. This is actually not N8, this is E7, but the device size is the same. So in my era of computing, for example, this type of a capacity of memory has gone million-fold within much smaller space, of course. That device was not very big, though. The 2014B is the size of a small refrigerator. I mean, I mean, at that time it was pretty small computer. Many of you must have seen Apple. This is Apple I. So it also looks different. So what's the mega trends that I'm talking about, and why I believe this is an era of computing that is very important? There are 2 mega trends that I want to just mention you. One is the one that I illustrated there, which is the sort of modified versions of the Moore's law, and where you can see that the computing capacity together actually with the memory capacity and storage capacity, which is a little bit different, but it's sort of related, is increasing still in a very, very, very fast pace. Regardless what you hear about Moore's law being dead or whatever, that's not true. It's still increasing. It's actually a logarithmic scale here, so it shows linear, but it's actually logarithmic. So one of the things we see that we get new computers, and the new computers tend to be physically smaller, which tends to usually bring new use cases for them. That's one mega trend. And in my lifetime, I have seen no slowing on this one. So the first real computers after the mini computer that I used at the university were Baroques and Sperry Univacs and things that you can see in the History Museum. I once went with actually my predecessor to that Computer History Museum, and we had a huge competition who has programmed more of the machines that you can find there. I won hands off. Because there are Commodores and Ataris and Sinclairs and all the microcomputer stuff. And also thinking machine, parallel process. Another mega trend is the web. Actually, that's wrong. The other mega trend is the net. But web sort of brought it to the consumer space. So we have 2 mega trends: connectivity, global connectivity, that is unprecedented, and we have computing power in devices of a generation of computers that is natively radio. It's a wireless device. It's also first generation of computers where you natively add sensors, cameras, accelerometers, location, GPS, things. These two megatrends colliding, or actually meeting each other, has caused the turbulence you see now. So for the, let's say, last decade, but actually it's even shorter time. That's the reason why you have players that you think are very different, like Google, horizontal service player, vertical players, computer manufacturers like Apple, traditionally embedded system device manufacturer like Nokia, all playing in the same space. Because these two megatrends have met each other. And that means that this era is the era of computers that are always connected. They are always with you. You have an emotional attachment to these computers to a degree that if you look at, for example, when the recession started, you must have read what was the ranking. I mean, when people were dropping, what type of things they drop, because, times are tough and you can't do that. Taking a cell phone on the, from, I think the 8th segment or 25 was that was the last one to just go. Because you would feel isolated socially. So we have these very funny computers that are very different now, and at the same time we have a worldwide distribution of information. Now, one interesting fact of this is also that on the web side, there's another computing world, which is people usually tend to talk about cloud. Cloud, in some sense, if one doesn't want to go to nitpicking on the things, is a returning to my youth, where we had mainframe computers and time sharing. There's differences, but it's actually very similar than having a big Xerox machine sitting somewhere and dumb terminals to being attached to that. By the way, this is not the cloud that is running Google. This is not the cloud that is running any of the data centers for Yahoo, eBay, or anything. This is a rather new data center that is running the so-called Tier 0 computing cloud part of the Large Hadron Collider in CERN, so-called data grid, one part of the data grid. So it's Tier 0, Tier 1 is distributed all over Europe, and then you go around. Because the original plan was to treat data that's 4.5 terabytes per second. It actually became much larger in the modern experiments. So you basically have to handle very fast, approximately a petabyte of data per minute. So that's one of the more interesting ones. One of the things that also happened as a mega trend in the world, in the net, was global communities were formed. There's nothing, if there would be a sociologist sitting in this auditorium, there should not be eyebrows raising. I mean, we always had communities. We had tribes. The tribes were basically limited by the geography, the distance you can go and meet somebody to do the interaction. Later on, we developed communication technologies like telephone and others that allow us to do this communication, in addition to asynchronous methods like books. Very, very good. And then later on, email to do a connection. So the web allowed us to do these global communities. So nowadays, we know very well that global communities, this is actually very outdated in numbers. You have various different types of global communities around the world. Notice, by the way, that from the North American perspective, always people think about Facebook and others. Most parts of the world, if you go then somewhere else from the Western world, you have totally different networks. It's not the same way like Google, Baidu beats hands-off Google, Yandex beats in Russia, Google. So you have to remember that when we look at the services, it's a little bit fallacy to think that there's unique global services that go across the world. Why is this important for Nokia research, or why is it important for me? Because our customers are in 220 countries in the world. And that means that I can't ignore what is happening in the 2 billion or 3 billion people in China, India, and Southeast. although we tend to, of course, here in the Valley, I live in the Valley, I live in Palo Alto, so tend to easily check the life to be different. I want to show you one video, which is 90 seconds, so it's not a long video, but it shows something about the scale. And this is not to promote Nokia, it's just to promote you to understand what scale we are talking about in mobile computing and mobile computers. This is Nokia-only specific data, so you can then add to, you know, an order of magnitude there to see what it would be if you put everything together. So the basic point is that the scale of computing we are talking nowadays is way beyond anything that you've seen before. And a couple of times I've been, actually it was before Nokia times, I was speaking about systems that don't scale down. Sounds a very interesting idea. But there are a lot of things that don't make sense if you have very few things. And they become very interesting if you have a certain scale. So for example, modeling traffic as a macro trend or seeing it doesn't make any sense if you have very few probes on the road. But if you have a certain percentage of the whole population being tracked, you could do a very good traffic models. Social networking doesn't make very much sense if you are the only other person in the social network and the other guy. If you have 500 million people in there, something very interesting also can happen. So the scale is very important to remember. Forget about that, so we're gonna go. Maybe I'm just gonna say something about Nokia research to explain to you that when you talk about research in an industrial research lab like Nokia Research, it's not only about research people. It's the people like what we call advanced systems engineering, guys who help to do the tingling and building things further. We need to think about, is there really something we could use from business perspective, these innovations that we do, so that we don't fall in the trap of Xerox PARC. We also need to basically look at the global spread, because it's very difficult to develop interesting things, for example, in Hindi touch input in the West Coast. But it sort of works much better if you are there in India. So this type of a very global reach needs to be taken account in the design. Now I want just to talk about something about on the topics, but before I go to that, one of the things that any good research lab has realized is that you never can do these things alone. First of all, there are always people who don't want to move to the research labs. They want to stay at academia. They want to work in their own ways in different places. So what we want to do is we always want to build networks with the universities. Notice that the positioning on the map of those dots actually is not defined where Nokia has factories or other places. It's defined by the great universities. So we are here because of Stanford, on the East Bay because of Berkeley. We are in Cambridge, Boston because of MIT. We are in Cambridge, UK because of Cambridge University. We are in Lausanne because of EPFL. We are in Beijing because of Tsinghua, and so on. The only exceptions being the ones that you see in Nairobi or others where we are there for to understand the culture and do ethnographic studies. You might also be interested in what are the areas that we want to work on that. So these are the 4 big areas that go across globally. It's not that one of these areas is owned by one global area. Very traditional ideas of different types of things in new user interfaces. For us, the new user interface means, for example, ethnographic studies in Africa to look at how the tribes are using the devices and understanding if we could build different type of communication networks for them, which cannot use data networking, for example, because 3G is not there. Or to data mining and sensing and building the different type of context sensors, to different type of computer architectures, and then to even to the notion of cognitive radio. Now, many of you must have at least got some kind of idea, as we are in engineering school, many of you should have a little bit better idea than just some idea, is that there are these different type of radio standards. Talk about 2G, 3G, LTE, sort of 4G, and again. Cognitive radio means I would say the limit in theoretical sense of the radio, which means that you do dynamic spectrum allocation in microseconds by the device looking at where there's free space in the spectrum. And you can secondary use, for example, a TV spectrum to use this. So cognitive radio, the name comes from it's sort of intelligent radio. And it's a humongously complex research challenge because you need to do tunable antennas and other things. Another dimension, instead of only looking at what we do, is to understand that we have different levels of projects. So not everything is like you typically have, that you would have a same size of projects, but it's more akin that you have, for example, in academia, that you have individual work, you have group work, and then maybe you have even the course people coming together doing the work. That's basically the sort of way we do it. Now, one has to then understand that as the investments grow, then there are fewer and fewer of the bigger things. The bigger things are big bets. And each of those upper corner things are bets that if they are successful, they should change at least 1 billion the revenue of the company. And then the smaller ones are then, more exploratory or incubation. I want to touch a little bit these things that selecting from the huge portfolio of things that we do in the labs, that to remind you that the type of the research or the topics can be very different than when you look at the smart devices space. Notice that I actually don't like the word smartphones, and I'm not using it. Because for me, first of all, everything is computers. Computer scientists say always everything computers anyway. But secondly, I believe that the phone name is sort of wrong to these devices because the majority of the use case is non-audio codec. It's not calling anymore. It's different types of messaging, browsing, data handling, anyway. What do you do then if you don't have the data network? Well, okay, I could argue that people occasionally talk about growth economies and developed countries where you don't have this type of good connectivity. Using that definition, part of 280 is a developed world, undeveloped world, because, the connectivity here is terrible occasionally. But basically, and the capacity problem, so in some sense, Silicon Valley, you could put this a dot in a growth economy in that sense. Now, basically, looking at this, it's very interesting to develop, for example, think about how do you do Facebook, but you only have SMS gateways. And yes, your devices can show some graphics, but they can't do data traffic transfer. How do you do positioning if you don't have GPS in the devices? Because that, again, is not a network question, it's a question of the price of the device. Because these devices that we talk here range anything from $50 to less than $100. Oh, it doesn't sound $50. I got my handset, it's $50. That's because you are in this very biased world where your carriers are subsidizing the devices prices to get you hooked with your plan. So your $50 device here definitely doesn't cost $50 for the carrier, but you're actually paying that device price in your 2-year locked plan, family plan, where you guarantee that without a $500 fine, you're gonna be, you'll be stuck there and you're gonna use much more money. So when I'm talking about $50 device, it means that the device itself costs $50 without nobody putting any money on the table for it, because this type of a subsidizing happens only in very few places in the world. We look at things like mobile health, real-time health care for rural areas in India. There's a tremendous problem of getting the health information, and there are not enough doctors to go around in a 1 billion person country like in India. And it's a very important thing, and I encourage you to look at some of the things that the people do. For example, in the humanitarian tech awards, we sponsor the health for reasons, exactly for these reasons. I'm going to take a totally different topic area as a second example, and that's the following. I'm a computer scientist, and this is an automobile, and you can think about that you have cars and you have systems. So some of the things that we've done is that we've taken the existing computer and embedded it in a car. So think about that you go to a car and actually it's wireless, so you put your device there. Anything that is on your device is accessible by the car's touch display, car's loudspeaker systems, any sensors that you have, so you can play your favorite music and others without having to install it and embed it in the car itself. Navigation, of course, included. We all know that why we buy separate navigation systems, because we don't like the sort of, so everything would be there. So you would have the car, you would have the car there at the lower bottom. You would have put the device in there and you would have everything accessible. Sounds cool, but that doesn't make me tick. What makes me tick is that the car is a beautiful platform of sensors. So this is some of the sets of the sensors that are in a car. So for me, car is a platform. It has power. You put the computer in there, and the car measures all sorts of things. Now, this computer is a wireless device, so it can tell these things up to the cloud, and then you can bring it back. Give you some examples. If you see here, for example, velocity traction control, the car measures all the time when it's slippery on the road, it does it. So when you have black eyes, the car detects black eyes, the computer sees it, beams it up to the service, up in the cloud. The cloud looks at other cars that are in the proximity and send a message to those computers in those cars and tell, hey, there's black eyes. What do you have? You have real-time black eyes detection. If you want to look at micro weather, microcell weather, it's very easy to tap into the windshield wipers of the car. If you have multiple cars in the area that have windshield wipers on at the same time, you super likely have rain. And you can do a very precise real-time mapping of, for example, of the rain condition. So car is an interesting new notion of a connected device, where you connect the mobile computer and a car, and you will see a lot of this type of things happening. Of course, traffic is one of the things we did with Berkeley. So one of the things we did with Berkeley is that put the device in the car, measure, just as like in a gas, you measure molecules, you can look at the traction, and you can do good traffic modeling. And you have the best traffic modelers in the world by just having these probes, meaning your handsets in the cars. Notice that you have your handset in the car anyway, so it doesn't need any special things. This picture doesn't show very well, unfortunately. Could we dim this? It would show a little bit better if we can dim just the front for a second. Okay, thank you. shows a little bit better. This is, you see sort of Europe here, Spain, Britain, Northern Europe, and the lights. What is this picture? This picture of part of Europe as seen by the location, navigation, point of interest queries of Nokia devices. There is no map underneath, notice. These are so the brightness of the spot tells how many queries were made at that particular location. This is about from 20 billion queries made on the Nokia navigation device. So you can start seeing how pervasive these devices and the navigation is in the world. Because you can draw the map, I could show the map of the world the same way. And you could see the different things just working there. Could you still dim one more time, sorry. This is a similar related thing, but animated. You see the green dots there? That are navigation requests because the navigator, meaning the handset, is asking different things. There's a clock going up there which you don't see very well. It's like early morning. And then you start seeing these things. And then you see this done. Those of you who know your geography well, or at least been traveling a little bit, will very fast figure out this is London. So this is an accelerated animation of the London because this is the ring roads around the London. And this shows the request that the navigators, the people who are using Nokia devices to navigate, are doing, in there, and showing the dots and the location of those navigation requests. Again, the point here is to show that we have entered an era where our collection of data with these billions of devices has become so powerful that we can build services what one could not imagine in the past. Okay, thank you. We can put back the lights. Finally, just as a sort of final, tries to do this constantly there. I promised to say that the spread that we do in the work also goes to nanoscience. But we don't do the nanoscience for just nanoscience sake. What we are interested in building is a totally different type of devices, computing devices, that allow you to do, for example, things like flexible electronics, so the device can be wrapped or opened like a book. Haptics, which are truly non-haptics, that you get the keyboard actually physically goes up. Super hydrophobic, so that when you spill your Diet Coke, I guess nowadays, in my times it was Jolt. Jolt on the keyboard, it will sort of flow away from that because it's super hydrophobic, it sort of repels the dirt. All these different things going then to the tunable antennas. So what we do with the nanoscience research is we are looking at the future devices and how do you build the future devices. And that's part of the bets. So you can think about when you do a big sort of research lab agenda, you put bets in different places. You put bets some places where you believe that it has the highest sort of interesting payoff on the things in the industry. You put bets in the places where you believe you need to have competencies, but you don't yet know where to use them. So there's very different needs of putting the bets in different places. Anyway, I always point out that we are commandos. We are not good at being put in a regular R&D, productization. That's a misuse of the people that I have. We go and make the bridgeheads. We build concepts, prototypes, solve problems, and then the soldiers come. And then they make the products and build there. And why do we exist? Part of the reason we exist is because of black swans. So part of it is because nobody can predict the future in the current dynamic landscape. Okay, I'm going to stop here because I want to give some time for questions. So, thank you.
I had a question about if it's not intrusive, what is exactly going wrong with operating systems on your so-called smartphone devices, which you don't want to address them that way, and your current partnership with Windows for the mobile platform. does that even mean that Nokia R&D and Windows R&D are going to start working together?
Oh, first of all, yes, of course, the partnership is going there. What's going wrong? It's an interesting question. I'm a computer scientist, so I'm not an embedded telecom person. I joined Nokia more than 6 years ago to Nokia Research as a research fellow, by the way, and not in the, to lead Nokia Research. And one of the observations that I would argue that, of course, it's very, it's always great to be clever and hindsight. You know, the bars are full of those guys who know the history. You know, they would have done things better in the history that was going. But a couple of points that one has to remember why Symbian, which would be a good example. There's nothing wrong technically with MeeGo, by the way. It's just a question of that MeeGo coming rather late on the game. The history of computer science shows always that it's very difficult to make two close-by operating systems to survive. So you remember OS2 never survived because of MS-DOS already had taken the space. So I'm just arguing, and I have a very personal relationship with Linux, meaning that I do know what I talk about in Linux. So basically, in Symbian, it was a Psion embedded device operating system that was stretched very far. Now, it's like your project work, if you're a computer scientist. You do your project work, and you know what exactly happens when you patch over stuff, and you just need to deliver every time because the damn professor wants to have this damn thing there. But at the end of the day, it's even worse if you take your buddy's former program and then just patch it a little bit more to get your next coursework done and patch it again. So you end up in the Symbian situation. So the slowness of the software engineering becomes evident. Adoption becomes evident. Coming back to your second question, I already answered. The partnership with Microsoft means that, well, by the way, you have to be very clear. The smart devices will use Windows Phone 7 or Windows Phone X by the end of the day on that. That has nothing to do with the next billion, for example, for our devices on the growth economies or what you nowadays tend to call the lower-end smartphones. So it is only a decision in one category of the devices. But yes, we will work together with the R&D on Microsoft side, even here in the Valley.
Has Nokia Research Labs developed any specific programming languages for their tasks?
No. No, I'm thinking about how to answer this.
Or like more so?
Oh, I do understand. I mean, first of all, there has not been any significant development of programming languages for the last 20 years. There's only been scripting languages that have been developed on top of the normal construct. So since C and C++ as an object-oriented version of C, when Stoustrup was doing that, remember that is 20 years old. So the only things that Pythons, yes, Ruby and Rails and Pythons and whatever, and let's put Haskell on side because Haskell is a functional programming language, so you're getting it. But Haskell is actually a true programming language, although Haskell's principles were quite old too. I used to do programming, functional programming, so a lot. So basically going, we at the labs know there are, of course, software environments that have scripting capabilities that would look, you could argue they would be like programming languages. We acquired something like QML as a developer environment. QML on top of Qt is a programming environment. It's such a hazy notion. So closest to your question would be what we own in Nokia would be Qt, QML, I guess. Which is cross-device. It's not only for Nokia devices, of course.
You had a slide with a roulette table, and you were talking about dividing up research and development into different assets, different programs, how much assets.
Yep.
Can you go into more detail about what you do to determine which get in and which get out? And do you divide up human resources and infrastructure and budget, or what do you do to make these decisions?
Yeah, a very good question, and probably something that any lab director or, like, you know, I don't know, well, anybody who heads research has to think about all the time and has to even modify all the time. There's a couple of simplifying things that I just want to mention. There's Henry's golden rule: he who has the gold makes the rules. So the first one is, of course, the investment, the monetary investment and empowerment then to people to do what they do, because you can't micromanage people. Some research needs different type of infrastructure. We have our own clouds, for example. I have a cloud in Dallas, one in London, and one in China, for obvious reasons. And, but what we do is that we look at the strategy of the company, and we align on, we try to identify critical technologies, enabling technologies to make things happen. Having said that, if we align perfectly with the strategy of the company, we are not filling our mission. Because our task is to also build to the possible futures of Nokia. So we are doing competence building in areas which currently you would say, hey, nothing to do with your business. It doesn't even look like that you would be there. That's the same thing like Microsoft Research does in the competence building. HP Labs maybe not so much. They actually much more focused on like in the top end projects. I have strategy people. I have a BD people, business development and strategy people. These people help me to look at this type of a portfolio thing. Again, one has to remember that research is not a quarterly business. You can't ramp up and down the research by saying, hey, this next quarter we're going to do programming languages, and this quarter it was databases. But what you can do is you can stop and kill projects that don't seem to be producing anything, or they really clearly become obsolete, occasionally for external reasons. So for example, partnerships like the Microsoft can make certain approaches unnecessarily because Microsoft research and R&D will actually solve the problems that we don't need to look at them.
Henry, we have a large number of students here who are mechanical engineering students that love to work on cars. So you showed the example of that the car is a wonderful platform for sensing and monitoring. Can you elaborate more of some possibilities there so that will inspire their thinking?
There's something, if you go to the web pages of research.nokia.com, you will find something called terminal mode. It's, by the way, a terrible name because I would think that the terminal mode gives a little bit different feeling on different things, especially if you think about elderly people. But basically, the terminal mode is the car industry's notion of a standard where you standardize this interface that you see that the computer talks to the car. So we developed that one. Now, having that standard, you can start plugging anything to the cars. And this is different from your fact that if you have an American car and you push an iPod in it, or on Apple products, because Apple actually controls that interface, and pissed many car manufacturers by changing. Steve changes it occasionally, and cars' lifetime is so much longer than the cycle of this thing. That's very different. So there's a standard on that one. So if you want to work like in the different dimensions of getting that information out of the car or getting information to the car, by the end of the day, Sebastian Trons, or nowadays Google, he's my colleague. He was actually in my field, so I know Sebastian well, from Stanford. The autonomous vehicles and various different sort of dimensions are all going to be somehow linked to this standard. You already have a standard interface for all the sensors in the car. You can read. That's the reason why your service guys can, when you take the car there, they plug it in and they read everything from your car, what has happened. Now, I'm talking much more because I'm talking actually mining and doing, for example, pattern analysis and analytics on that data, which they don't do that much. But in principle, it's the same principle. And terminal mode is a communication protocol that allows you, these computers, to talk to the cars. That's actually very powerful, very interesting. And for your future employment, please do remember that BMW, Daimler, and Volkswagen all have research labs in the Valley. I don't know how many you just sort of realize, but these big car companies have their research labs in the Valley. And that's the reason why this car terminal was not done in Europe, as you would imagine. It was actually done in Palo Alto lab. So that should be encouraging for the future employment prospects for somebody. Thank you.